Okay, welcome to lesson 7 of learning to program computers with Scratch. This is a recording of a live lesson, so there might be some dead sound in between while we are busy working on the computers. Okay, today we are going to do quite a lot of stuff. We are going to have a look at data types and variables. Okay, we're going to understand variable scope and how to use monitors for the variables and how to handle variables when it comes to clones, which is quite important. We're going to learn to get input from a user. Do you know what that means? Okay, so when you interact with a computer program and it says what level do you want to go to, you say I want to go to level 3. So that's the computer asking you for something. So that is called the computer getting input from the user. Okay, we are going to follow through relational operators, which I'm sure you've done in maths before. It's less than, greater than, equals to. We're going to have a look at the modulus and the join blocks. The modulus block is a maths block. You know what that is? So modulus is basically the remainder of a division. So if you say 5 divided by 2 equals 2 remainder 1, where normally you would be interested in the 2 part as your answer, with the modulus you remain interested in the remainder part, which is 1 as your answer. And we're going to look at the join block, which we use to join strings of text together. And then we're going to have a look at decision structures, which we have already touched on a little bit before. Okay, so what is a variable? When you hear about a computer, you hear about the screen and the keyboard and the CPU, and then you hear about the hard drive and the memory. The hard drive and the memory are what we call storage. Hard drive is long-term storage, so when you switch your computer off, the information stays there. When you switch it back on, it's there for you to retrieve. The memory, also called RAM for random access memory, is where the computer works with data while it's switched on. When you switch your computer off, the information in the RAM disappears. Another word for the RAM is called volatile memory. So it's volatile as in it can disappear. So when we work with data on computers, we need somewhere to store it, and the tool we use from a programming point of view is called a variable. Okay, now you get different kinds of variables, but basically the basic thing is that a variable stores information that you need for your program to work. Okay, so for instance, if you selected yes, we need to store that the user selected yes, because it's going to influence what the program does down the line. If you are playing a game and you get through various levels, we need to store how many times they got through the levels. Or if you are asking Google Maps, show me how to get to Cresta, it needs to store that Cresta is the target when it's doing its route planning. Okay, so typically if you have a look at a variable here, you can think of it as a little box, and it has a name, which we call side in this case, and it has a value, which is the contents of the box. The name and the contents or the value are not the same thing. The name is just a tag or a handle for you to hold on to the data. Now in this example we've shown that there's one value, 50, for our side, but in reality, and we'll cover this in a later lesson, you can store multiple values in a variable. Okay, so bottom line, variables help programmers to remember or store information. I think that might be Des. Let's just pause here. Where's that gone now? Okay, and we are back, hopefully. Let's just confirm that. Whoops. Recording. No, we're not recording. Pause, pause, pause. Continue. And we should be recording. Okay. Alright, so we are back on our variables. Whoops. And how to use them for our programs. So before we jump into variables, we need to learn about a thing called data types. Okay, Scratch is very forgiving when it comes to what information you put in what variables. Okay, but normal computer languages, so C, C#, Python, whatever, they're a lot more strict. Okay, so if you say I'm creating a variable which is going to hold numbers, and then you go and put a string of characters in it, your program's going to fall over. Okay, it's going to say your definition of your variable isn't matching the value you're putting in, and I'm just not going to work with that. Scratch is very forgiving because it's a program for or language for beginners. It really you can't break it. Okay, you might land up with some weird results because you put a string of characters into a number and now you can't add it to some other number. So you might get a weird value out, but it won't break the program. But there are three kinds of values in Scratch and more than that in most computer languages. The first one is Boolean, okay, which is true or false. Okay, doesn't always have to be true or false. It can use 0 or 1 or yes or no, but the point is there's only two values. Okay, it could also be -1 and 0. Those are Boolean values, and you'll see in Scratch wherever you have a little hexagon type shape, sort of a squashed hexagon, that indicates it's a Boolean value. So for instance here in mouse down, okay, that's really a question. Mouse down question mark. The only two options are yes or no. So this is going to give a Boolean output. The second set of data type we have is a number. Okay, numbers come in two flavors mainly. You have integers, which are 1, 2, 3, -4, 10, etc., which don't have a decimal component, and you have decimals, which do have a decimal component. So 1.4, 34.24, billion, 0.67, whatever. The reason they are classified differently is because the way the computer stores the information internally has to be different depending on what kind of number you're going to be putting in there. And then you get your most generic form, which is a string, also a character. That can be Bob, hello. You can even put numbers in there, 5 plus 3. It's not going to say 5 plus 3 equals 8. It's going to see 5 plus 3 in the same way that when you type up a document in Word and you put 5 plus 3, it just thinks it's another kind of text. Okay, so if we have a look at the shapes of our blocks, anything that's a squashed hexagon expects a Boolean parameter. Anything that's a rectangle with right angle corners is a string parameter. Anything that's either a rectangle with rounded corners or circle is a number parameter. But Scratch, being very friendly, it is a bit flexible. So you could put your Boolean operator into your Boolean field or into your string. Okay, so for Boolean it will treat it as a Boolean, true, false. If you put it into a string and you say string, it'll say true, T-R-U-E, or false, F-A-L-S-E, which is useful. The same goes for numbers and strings. Okay, they can either go into a string block or into a number block. So if your answer is 1, 2, 3, you can say 1, 2, 3. Whereas if you say change x by 1, 2, 3, it'll add x to 1, 2, 3 and give you a new position. Okay, so how do we create variables? Okay, before we go into it in the program itself, we'll just have a look at what the various options are that you get. The variable itself is a little block with rounded ends with your variable name. Okay, then you have a couple of blocks which you can use on that variable. The first two are really the only two important ones. You've got set rand1, in this case rand1 is our variable, to 0, so that gives it a definitive value. Then we also have a change, which will increment it. So you can change rand1 by 1 or -1 or -1,000,000. Any value which makes sense. It's important to note with the change block, it doesn't really work well on strings. So you can't have your variable in ABC and then change it by DEF. That doesn't really make sense. So your change block you typically only use on numbers. And then we've got two blocks called the show variable and the hide variable block. And these are just shortcuts for in your program to check and uncheck that box. So if we jump into Scratch quickly and we go...
That sounded get the thing of the school.
Yes, yes. So if we go and we click on make a variable and we give it the wonderful name of rand1, okay, first thing you'll see is it puts in your variable there for you, and then it puts these 4 blocks in. Now it doesn't put these 4 blocks in every time you create a variable. So if we go and create another one called rand2, It adds rand2 in, but it doesn't add another set of blocks. The reason being we have a drop down. So we can,
this applies to all of the variables.
yes, so we can go and choose which variable we want to use when we use our block. Do we want to use rand1 or rand2? Okay. So the other thing it does is it plonks these things onto your stage. These are called variable monitors, and it lets you have a look into what the value is of your current variable. Okay, now we'll cover this a bit more later on, but you can hide and show your variables. They don't have to be on there, and you can also use your hide and show blocks to achieve the same thing. Okay, that's just if you want to do it in code. Alright, we will be coming back to some of the other elements of variables, but let's get started with using them. Okay, so we've been through how to create them. One thing you might have seen when we created it, there was options for all sprites and for the sprite only. That is called whether or not the sprite is local or global, and we'll cover that in a later slide. But just for now, it always defaults to for all sprites, and if we have the for all sprites option set, it means that all sprites can see the variable and change the variable. Okay, right. So let's do some maths quickly. Okay, so we've got a nice long sum here, and we've written it out in the Scratch blocks format, and you can see it's actually quite difficult to read. Okay, so what we can do is we can break it down into using variables for our numerator and denominator. Alright, so we've got our 1 divided by 5 plus 5 divided by 7 as our numerator, and our denominator 7 divided by 8 minus 2 divided by 3. Remember, the blocks are implicit parentheses or round brackets. Okay, so we don't have an explicit one in the Scratch because the blocks implicitly encapsulate the fact that there are brackets there. So that simplifies our formula quite a lot, because we've gone and put our numerator into one variable, put our denominator into another variable, and then we just use those two variables in our equation down below. If you go and have a look at the computer memory, we've got our numerator and denominator as two variables, and the value inside is actually the calculated value of these two sums. Okay, we can take it one step further, and we can actually break each term out into its own variable. So instead of just having numerator and denominator, we can have a, b, c, d. So a, b, c, d, and then we put the individual equations for each of them, and then we build up our sum again like that. Okay, again, if you have a look at the memory of the computer, it stores the final result of your equation. It doesn't store the 1 over 5, 5 over 7, etc. Okay, now there's no hard and fast rule on how you use your variables. It's really up to you how much effort you want to do or put in to achieve maximum readability. Okay, so as you can see, if you break it down to the nth degree here, you land up with 4 variables. If you only do it numerator and denominator, you have 2 variables. So it's really up to you. The one thing I should note here is, here you haven't made your program more flexible, you've only made it more readable. Okay, here you've made it more flexible because now you can go and set those independently. So if I wanted to change my equation to have this element be 6 over 7, I would have to go and change it here for the numerator. Okay, so the whole numerator value would change, but in this one I would only change my b value, and the rest would all stay the same. Okay, so we're going to do a little dice simulator. I think because we started late, we'll just go straight to the coded version and I can explain it to you. But basically what we have is, we've got a little guy in the left hand corner. He's going to roll the dice. There's 2 of them, and it is going to flip through the values on the die to sort of simulate the rolling action, and then when it settles down onto a final value, he's going to tell you what the final value is. So if we go and load up, okay, and we go to our exercises, And dice simulator. Okay, this is on your flash drives if you guys want to have a look at it at home. Okay, so let's run it first and see what it does. Okay, so we have our dice spinning, and then he tells you what the sum of the two die is. So 4 plus 2 equals 6, and every time it picks a different set of numbers. So it uses the random function to achieve that. And how do you think he gets the dice to spin? Costumes, right. So we are flipping through the different costumes, and each die will have 6 costumes because there's 6 sides to a die, and they both look the same. But if we look at the code, there's no code on the stage, but there is the backdrop, which has the title and the border. If we have a look at our little character, okay, I'm just going to stop here. Okay, he sets 2 random numbers. So if we have a look at our data, we've got 2 random values or variables, and the monitors are unchecked, so they don't display on the stage to give the game away. And it picks a random value between 1 and 6 for both of them, and then we broadcast a roll message. That is to go and get the die to fake their rolling action. So in each die we have a when I receive roll, we repeat 20, and then we switch the costume anywhere between 1 and 6 because there are 6 sides, and then we switch the costume to rand 1 for the first die and rand 2 for the second die. If
How do the numbers correlate with the costumes?
If you have a look at the costumes, you'll see they are
Okay, so
numbered.
those
Yeah,
numbers do fit
yeah.
in.
So by default, as you add sprites to your costumes to your sprite, they get a number value which you can use to reference them. You can also set a name for them. So costume 1, 2, 3, 4, and you can also reference them by name as well.
But obviously for name you'd have to do each
Yes.
value for costume.
Yes, yes. So that obviously makes it more complicated, which is why we use the number thing here, because it works well with the random function. Okay, so each of our die roll, and when they've finished rolling 20 times, then they display the costume that the guy chose. Okay, we had an and wait block here, so when they are finished, then he carries on to say what the value on both die are. So a pretty simple example, but it quite effectively displays how to use the variables for our die. Okay, so this is just the scripts that we've been through. Okay, something to point out here is we put the variable value in our parameter for our switch costume, even though it didn't look like it could receive a variable, because we're used to having these little white circles or rectangles, so we know we can put something in there. So if we just jump back to our code and we take our variable out, you can see there's all the costumes. Okay, but we could just as easily drop our variable in, and if we didn't already have it, we would go and fetch it from our palette over there. Okay. Alright, now variable scope is quite an important thing. What that basically means is you have, by default, like I said, when you create a sprite, it marks it as for all sprites. You also have it for this sprite only option. For all sprites means all the sprites in your project can view the variable value and change the variable value. If you set it to for this sprite only, all the sprites can still view the value, but only the sprite that you created the variable in can change the value. Okay, and it does it quite cunningly, as we'll show now. Okay, if we go and create a variable, actually let's add another sprite first. Okay, so we've got 2 sprites, and if we go to our cat sprite, make a variable 1, call it var1 with my terrible spelling. It's amazing I actually get programs to run. Okay, var1 for all sprites. If we go and look at sprite 2, we can see var1 there. If we go back and we create another one called var2, but we make it for this sprite only, okay, you'll see when we go to our second sprite, it doesn't appear. So it's not available at all. Okay. Now you think, okay, so how do I go and see the value? Okay, because it's not here in the drop down. There is a sensing block, and you go to this one down here, exposition, and you'll see at the bottom, if you choose your cat sprite, okay, it has added the variable at the bottom. So that is how you get the value out for a local sprite. So the sprite, I mean the variable, which belongs to the cat, we are getting the value out, but we can't change it because the change and set blocks don't contain it.
Can you give me a quick example, like, of how you would use that, like in a game or whatever?
So typically what you will end up doing a lot of the time when you're writing a program is you're doing loops, okay? And when you do a loop, you typically have what you call a counter or index to say how far you are through the loop. And programmers use super creative names like I, J, K, etc. to name their variables. Now you would want that variable to only be modifiable in that section of code you're working on, because if you have two loops in different parts of your program which might be running at the same time and have the same variable name and they are global, then they could interfere with each other. So in that case you make them a local variable, so they have their own name but they're separate from each other and they can run quite happily without interfering.
And for this type of thing, obviously, if, say, this sprite is sensing what's the variables of the other, you don't necessarily want it to interfere with that, but you want to see what's
Yes,
variable that.
100%, yeah. The other thing to note as well is for the first option, for all sprites, that's what your variable monitor looks like. For the second option, for the sprite only, it puts the name of the sprite in front of your variable monitor. So that's an easy way for you to know if this is a local variable or a global variable. Okay, so if we have a look at this little example quickly, we have when green flag clicked on our cat, we go into forever loop and it sets the count variable to a random number between 1 and 10 and then it waits 1 second. Okay, the penguin, which is a second sprite, okay, can get the value of the variable but can't change it. Okay, so that's example 1. We'll come back to some other examples just now. Okay, so to use our variable blocks, okay, we've got the set, okay, command. In this case we're setting it to an integer value. In this case we're setting it to a decimal value. Okay, now important to note, in Scratch when you're moving around on your stage, all your coordinates are integer. If you tell it to go to 3.4, it'll most probably go to 3. You tell it to go to 5.7, it'll most probably go to 6, because the points on the stage are discrete values. When you're doing maths, so you're calculating the volume of a rectangle, there you're more than welcome to go and put in decimal values, because it will retain that information when you're doing your calculations. Here we're setting side to A, which is a character, okay, and here we're setting side to ABC, which is a string. The only real difference between a character and a string is the character is single, string is multiple. Okay, so depending which way you look at it, one is the superset of the other. Okay, here we are setting side to a mathematical formula. Okay, in this case 5 is less than 10. We know that this is a hexagon, so the output's going to be Boolean. So is 5 less than 10? Yes it is, so the answer for this block is going to be true, so we're going to set side equal to true. Okay, now like I said in the beginning, Scratch goes above and beyond to protect you from yourself. So if you go and put nonsense into side and then say move side steps, the program won't break. Okay, but it won't do anything either, because internally it'll convert nonsense, which is a string, which you're trying to use as a number, and it'll change it to 0. So your thing won't move. If you set it to 100, which is a number, and tell it to move 100 steps, then it'll move 100 steps without a problem. Okay, so now this is how we change variables, and I'm just going to actually do this to demonstrate it to you guys. Okay, so we had some delta. Alright, so we're going to create two variables. I'm going to make them global for the meantime because we only have one sprite, so it doesn't really matter. Okay, and we're going to use our set blocks times 2, and we're going to set our sum to 0. I'm going to set our delta to 5, and then we are going to change our sum by delta. Okay, so we're going to change sum by delta. Okay, so we have two variables, set sum to 0, delta to 5. Change sum by delta means take the value of sum, which is 0, and add 5 to it. So sum should then be 5. So if we run this, okay, it's a bit small here, but you can see sum is 5 and delta is 5. Okay, if we set sum to 100, okay, and we ran it again, alright, our sum changes to 105, but our delta stays at 5. Now this is a common thing that we do in computer programming all the time. It's called incrementing or decrementing a variable. So you might have a game where you've got 100 lives, and every time you fly into the wall you deduct a life. Okay? Every time you manage to fly over the wall you add a life. It's a common thing that we use variables for, and this is one way of doing it. It's actually a shorthand way of doing this. So instead of saying change, we're going to use the set block again. I'm going to say set delta to, where's our plus? I'm going to say set delta to sum plus delta. Okay, and if we do this, it's going to give us, I'll do it the right way there. Sum plus delta. Yes, you're right. So if we do that, okay, so our delta stays at 5, our sum goes up to 105. Now you guys might have heard of a programming language called C++. Okay, the plus plus is actually a play on the way the programming language works. C programmers are incredibly lazy, so they have very minimal amounts, or they don't have a really sophisticated language, so everything they do have does very small things. So like I said, going x equals x plus 1 is something you do a lot. The C people just truncated that whole thing down to x plus plus. Take the current value of x, increment it by 1. They do the same thing if you want to decrement. X minus minus will decrement it. Okay, so that's the important concept. You'll use it. The last example is just building on that. That doesn't really add much. Okay, so now we're going to draw a spider web. So this is where you guys jump in. Okay, so you're going to go File, New Project, and we're going to include a whole bunch of stuff we've done before. So we're going to be drawing triangles, we're going to be drawing hexagons, we're going to be using our custom blocks with parameters, which we've covered. Did you manage to get through that?
I've gone through the custom blocks. I think that's the beginning part.
That's the purple stuff, yeah. But
so this is
okay.
but it's fine. I'm gonna be able to have time to go through.
Alright, okay. Now the reason we're using a variable here, the orange block called side length, is because we're going to start off drawing a triangle, then we put 6 triangles together to get our hexagon, and then we want 5 of those hexagons but of different sizes. So every time we do our loop for our hexagon, we need to increase, the side length by 15, and that's how we draw it.
We don't need to. Okay, sorry. This is we're just naming it. We're not adding in any
Parameters. So the spider web has no parameters, the triangle has a length parameter, and the hexagon has a length parameter.
So I'll add that one.
Yeah. No, your length must always come from your purple block. So you can't cross them between blocks. Because in effect this length is a local variable to this custom block. It can't be used outside of the custom block.
You define that in here, not?
Which one? Triangle length. Just go on your options. Okay, just click on your length there, over there. Just kill it.
Oh, okay.
Yeah, and then you're going to add a number. So click on the number, and then you'll type in length there.
Obviously
Yeah.
copied, looked like it was a square.
Sorry. Okay, the code on your triangle and hexagon is pretty similar.
I think I now starting to understand why my little game that I was making didn't work. Some of it worked, and then I added another component and it didn't, one of the spots didn't work properly. But I think
Okay.
it's because of variables.
Now I saw a cool tweet recently. It was quoting one of the early programmers, and he said after the first week of writing a program and realizing how much time he spent on fixing the program, he realized that hunting for bugs would take up the majority of his programming career, which is very true.
Okay, what am I missing?
Okay. Which one are you on? You're on your triangle. Okay, so you're going to drag your length
From there.
into there, yeah. Okay. I'm not sure who that is. Let me just go check.
That's funny.
On the right track there, because the code I have doesn't show you how to do the actual drawing. So you're going to have to add your on green flag click and set up all your pen stuff.
Okay, so that is the variable. You have to set a variable.
Yeah, so you're going to create a variable called side length.
I'm not quite sure where I am.
Clear, pen down. Okay, so if you have a look at your code here, you start off with spiderweb, which calls hexagon, which calls triangle. So the only thing you have to call is spiderweb, because this one will call the other two. So it cascades down. There we go. Cool. So you can obviously, yes, you can hide your sprite and you can fiddle with your side length if you want to make it bigger. Okay, and then you need to set your pen up. So on your green blocks, you'll do a clear. Well, you can if you want to clear it every time. Then you can do a pen down, and you can set your pen size and color. No, you can leave your pen down, but then you need to call your spiderweb block to get it to actually start drawing the spiderweb. you go, and you should be good to go. There you go. Very nice. Very nice. Michelle's got a rainbow spider going. Cool. Alright, so did you understand how we used the variable to increase the size of our hexagon slash triangle every time we did a iteration?
So basically it's staying at the starting point and it's drawing a slightly bigger triangle every single time.
Mm-hmm.
Yeah.
You can see if you change the color that it goes over the previous
Okay.
color every time.
Yeah. Okay. So now we're going to do a similar one. This is on your flash drive, by the way, Spiderweb, if you want to have a look at it at home. And we're going to do a similar one called pinwheel. Okay. And in this case, we have two custom blocks. We have a pinwheel one, and we have a pins one. The pinwheel has one parameter called count, and the pins one has two parameters called count and length. Okay, we also still actually need our triangle block, which I think is on the next slide, yeah. So let's just get these two down for starters. Okay, I do give the code for the triangle on the next slide. Okay. Pop onto the next slide, which basically defines your triangle, which is pretty much the same as the one in the previous example, and setting up our drawing as well. About that, yeah. One of your values was a bit wrong somewhere. Okay, just need to bounce back. Michelle's one is going a bit crazy. I think your repeat was supposed to be 25 there on your pinwheel. And your side length to by 4. You used the set instead of the change. Okay.
There we go.
Awesome. Should I go to the next slide for you?
Just want to make sure, okay,
Alright.
that I've got everything.
Mhm.
That's right.
Okay.
Head down.
Yes, that usually helps.
Yeah.
Usually helps. And if you change the value there, you should get different shapes popping out.
Not.
Still not.
That looks right. That looks right. Move length. That looks right.
Mhm.
Where are these lengths coming from? I'm trying to find like where does that?
Well, it gets passed through. So you start off pinwheel by 5, so that becomes your count. Then you change your length by 4 every time. So every time you go through this loop of 25, it increments the side length by 5, and that gets passed to your pins as length. Still no.
No. Is it mine? Maybe because. Okay, so that's good.
Okay, let's go back. Let's have a look at pins. Define pins, count and length. Count length. 10360 count degrees. Yeah, that looks good. Pinwheel. Count set pin color 0. Set side length. Yeah, to 0. 25. Change pin color by pins count side length. Yeah, that looks right. 0, 90, 120, 1 pin down, clear, pinwheels 8. That looks good to me.
What am I missing?
Does it do anything?
It just spins.
Maybe try hydrostrike floppy
Mm.
setting.
Just click on your info panel there. And then you can just click on show. There you go, very small.
Okay.
Did you change your side by 4 there?
Oh, okay. Yeah. Do what?
Oh boy.
Okay.
There we go. Okay, that looks better. Okay, so we both got the gist of it. Okay, and how we used our variables to make different numbers of sides. Okay, alright. And this is also on your flash drive, pinwheel.sp2. Okay, now variables in clones. We've done clones before, and we noted that when we did clones, they are point-in-time copies of your parent sprite. So whatever the settings and configuration of your parent sprite is when you create the clone inherits those. But thereafter they become independent of one another. And the exact same thing happens with variables, okay? For local variables, which are also the sprite-only variables, this clone will have the values of whatever the parent had, but thereafter they can drift. Because if the clone increments or decrements or changes their variables, that will not be passed back to the parent, and likewise if the parent changes their values, it will not be passed forward to the clone.
To an existing clone. A
Yes.
new clone.
Yes. Global variables are the same as if you had different sprites. The clones can read and change the values of the global variables. Okay, so we're going to do a little example here on cloning and local variables. So we're going to create clone ID as a local variable, or for this sprite only, and then we're going to create 3 clones, and we're going to see how they act independently.
So that one is for all sprites, right?
No, local. So for this sprite only, yeah. So not the default option, the one to the right. Mm-hmm. Says under looks, yeah, it's a bit confusing. I think they ran out of categories and didn't know where to put it.
And sometimes the color as well. Hard to see.
Yeah, the colors on the slides also sometimes get a bit distorted. So especially the sort of mustard color and the brown color and the blue and the purple. Yeah. Okay, so if you run it, you should land up with 3 clones, each saying what their ID value is. And you can see it was the value of the ID when they were created. Okay, now we can mix things up a little bit, and just before the say clone ID, we can put in a change clone ID by 1. Okay, and then see what the value is. So if your program's running, just stop it.
Wait, what did?
So that change,
Change the clone ID to someone
yeah,
else.
so that block, duplicate it and put it just before the same clone, or between the when I start as a clone and the say clone ID. Okay. Okay. So now there should all be one more, but if you have a look at your variable monitor for your parent, it should still be stuck on 3, eh? Yeah.
Sorry, just say that again.
So your variable monitor stuck on 3, but each one of your clones should be one more. Okay. Or you could have also changed it by 10. That might have been a better example.
Okay, so that's just gonna
Yeah.
create a lot more.
So there, yes, so their IDs are now way different from the parent, but the parent is still stuck on 3. Okay, so that's clones and local variables. Now this one is for clones and global variables. So file new project. We're going to create 5 clones, but our num clones variable is for all sprites. So the default option, and on each clone we're going to get it to go to a particular spot on the stage, which is random. Say hello for 2 seconds. Change the number of clones value by -1. So decrement it and then delete. Once all our clones have disappeared, the master clone or the parent clone will say game over. this kind of logic that we've got going here is actually used in a lot of programming languages. When you use variables, you obviously consume memory in your computer, and if you never reclaim that memory, you'll eventually run out of memory and your computer will crash. So what the languages do is they keep track of how many times or how many instances of a particular variable are in memory, and when that count reaches 0, then they know they can reclaim the memory for that variable. There is another more modern way of doing it called garbage collection, which is a bit more advanced, but the original way of keeping count of things is still used in a lot of areas. Well, there's not much to explain unless you're going to do computer science, because garbage collection is sort of a higher level of programming, where the programming language itself keeps track of stuff. When it comes to maintaining or keeping count of how many references you do or have, that's more in sort of your less well-endowed programming languages like C, where you have to keep track of your variable counts, because there you manually allocate memory for your variable usage. In a more modern language like Python or C# or one of those things, it gets handled automatically for you. You can do what they call disposing of your variables, but unless you're doing graphics or something that's likely to consume a lot of memory, you don't actually need to do it most of the time. Why do you think our X and Y number range is different? Yes, your stage is not square. Your y-axis goes from, I think, minus 240 to plus 240, and your x-axis, and your y-axis goes from minus 180 to plus 180. So they don't have the same range. Okay, get yours working. Okay, so it randomly creates clones, or clones pop up at random intervals between 0 and 10 seconds, say hello for 2 seconds, then they delete themselves, but before they do that they decrement themselves. And then the main program is checking to see when number of clones is 0, and when it reaches 0, basically game over. Okay, variable monitors, we might have touched on this a bit before. As I mentioned, you can quickly see your local or global scope just by looking if there's a prefix in front of your variable name on the monitor. If there is a prefix, like we see here with cat, it means it's a local variable, so for this sprite only. If there's no prefix, like the speed, then it's a global variable, or for all sprites. Okay, so if we just go back and do a little demo. So we create our variable, call it Bob, because Bob is cool. Alright, we've got our variable monitor here. We can hide it by unchecking that. We can also use blocks if we want to hide and show in the program. So if that runs, it hides. If that runs, it shows. Okay, the other cool thing is we can change the way our variable monitor looks. Okay, we can get rid of the label. Okay, this is useful if you have a game and you need to show a score somewhere. So you might have a fancy scoreboard or something, which is background artwork or another sprite, and you're just showing the value there. If you want to get more creative, you can go for the slider option, which gives you a little slider so that the user can, while the program is running, change the value of the variable.
So, tell me, like, when you say, for instance, you saved your little program, you uploaded it online, double clicked on it, when other people load it, will it just look like that, or will it display like score?
It'll look at however you had it when you saved your program, yeah. Because you can't go and change the way this looks using your blocks. So you have to manually set it up when you're writing your program. Now this is a very cool thing because, like I said, it lets your user change the value while your program's running. But sometimes you want to limit the range. So if you say pick a number between 1 and 6, you only want them to pick a number between 1 and 6. So what you can do is you right click on it, say set slider min and max values, which default to 0 and 100, and you could change it. I want it to be min 1, max 6, and then you'll see your minimum value is 1, and as you drag it, it can only go up to 6. Okay. Alright, so that is a cool part of your variable monitors. Okay, so here's a nifty little basic example where we're going to use our variable slider to change the background color of our stage. Okay, so first of all, this is going to be a stage script. Okay, and obviously to delete variables, you right click on the variable and just say delete variable. So we're going to make a variable called color. Pick your American or English spelling as you please. And then we are going to have when green flag clicked, do a forever loop, go and find our change color, set color. That's quite important. There is a set color and a change color. If you use a change, you're not going to really get the effect you hope for. And then we're going to put our color variable inside the color block, inside that one. And we're going to change our monitor to a slider, which by default is 0 to 100. We're going to take it up to 200. And then if you run your program and fiddle with your slider, okay, you'll see your background color changes. Okay, this is the kind of interaction I was talking about, where while your program's running, your user can change the value of the variable. Did you get that working, Michelle? It's a little bit slow on those laptops, unfortunately. Okay. Can you come right there? Okay. Alright. So now I'm going to take you onto a hardcore example. This is on your flash drives, so you can load it up if you want, but I'll load it up quickly. It's called Ohm's Law. Okay, so do you guys know what Ohm's Law is? Okay, Ohm's Law is an equation which tells you how your voltage, your current, and your resistance, when it comes to electricity, work together. So we've got our equation here. Voltage equals current times resistance. We get our voltage from our battery. The current flows through our wires and our light bulb. And our resistance is how much resistance our light bulb is offering. So if we run the program, voltage starts at 0. If V is 0, then current will be 0. Doesn't matter what your resistance is. Okay. If our voltage goes up a bit, our current goes up a bit. The more current we have going through our light bulb, the brighter it's going to get. Okay. Resistance is going to kill our light. So if we have a nice bright light, but we push the resistance up, our light gets dimmer because our current is going down. Okay. So here you can see we've got 3 variables. 2 of them are sliders, which means the user can interact with them. Okay, and 1 is just a monitor showing you the value. This is quite cool for if you need to do an interactive demonstration, because it's better than just having a picture and saying, well, that's the formula that applies. You can actually let the user interact with it and see what it's doing. If we have a look at the
export scratch stuff
to what?
Just thinking if you want to do something like for like lessons at school, like a PowerPoint.
You couldn't do a PowerPoint. It does have a record video option.
Oh, okay.
So you can record a video of the program running. That's about as good as it gets, yeah. So if we look at the code, okay, when we start off on the stage, alright, which has just got the basics of our picture behind it, we initialize our variables. So we set them to 0 for voltage, 1 for resistance, and then we keep checking forever, because all the time while the user is busy working it, we set our current to voltage divided by resistance, and then we broadcast an update and wait. That broadcast goes to all our other sprites, because we are going to change the size of our V and our I and our R depending on what happens. So to set the size for our voltage, it's equal to 100 plus 10 times your voltage to make it bigger. For the equals, it does nothing because it's just a decorator. For our cleanup, for our current, we set 100 plus 10 times our current, and for our resistance, it's going to be different. I thought it would be different. Set 100 plus 10 times resistance. Okay. And then our light bulb, how do we make it brighter and darker? We just use the ghost effect. Yeah, so nice shorthand. Okay. Alright, so very basic program, very nice demonstration of how to use variable monitors. Any questions so far? Okay, you want to break for some coffee? Sure, we can break for some coffee quickly.
Yeah, sure.
Let's just pause this. Okay, we should be back. Alright, as I said, on your flash drive, if you want to have a look, Ohm's law.sp2. Okay, user input. Having computers doing stuff, awesome, but most of the time we want them to do stuff for us. So we need to give input as to what they need to do. So if you are busy doing stuff in Excel, you put stuff in the cells, you create formulas, linking cells together, etc. That is you interacting with the computer, giving it input which it then manipulates based on what you've told it to do. So in Scratch we have what we call the ask and wait block, okay, which is literally this blue block called ask and wait, which will then pop up a little message box at the bottom of your screen. Okay, it will look different depending on which way your sprite is looking. If your sprite is visible on the screen, it will pop up a little speech bubble with a question. If your sprite is hidden, then it puts that question just above the text box where you type in. So if we have a look in our Scratch editor quickly, we'll find it under our sensing. No, I lie. Where do we find it? It is under, there we go. Ask and wait. Okay, and if we run that, what's your name? Type in your name, Bob. Hit enter and nothing happens. Okay, reason being is we need to store that answer somewhere, and that comes with the answer variable. Okay, so there's a built-in variable which is linked to the ask block at all times, okay, and that will store your variable. So if we go and say what the answer is, okay, and we go and say what's your name, and we type in Bob, then it picks up the value that we typed in and it can say it back to us.
How do you put Bob there?
We're going to cover that. Okay, we're going to cover that. Okay, so we are introducing a new block called the join block. Okay, join block is for our strings if we want to put them together. It's under our operators collection, and there we go, join block. So it's pretty much as simple as put the stuff you want in the front in the left, stuff you want in the right, and then it joins them together. You can nest them as well. Okay, so if you've got a lot of stuff you want to join, you can put them together like that. Okay, and then you would obviously put all the bits and pieces into join. Okay, so let's give this example a try. Okay, so in a new project, okay, when our space key is pressed, we're going to ask how old you are. Feel free not to use your real age if you feel that way. And then we're going to join whatever the person types in and say this is how old you are, and then we're going to say how old you will be in 10 years time. Okay, important point to note when you're using the join block. In order to make sure there's a space between the two items that you're joining, you have to put a space in. Okay, if you don't put it in, the computer doesn't know any better, and it'll just smush them up next to each other. There you go.
Only problem is here, what if somebody like for this answers with not just a number?
Then you will test it and see what happens. Remember I said Scratch is very good about protecting you from yourself.
Yeah, so I'll probably just so it's gonna take numerals.
Generally what it does, if you type in a string and it's expecting a number because you're using it in a maths thing, it'll just set the value to 0. Yeah, so if you run this and press the space bar, or not, depending which way you coded it, there we go. Yep. Okay, and feel free to type in Bob for your age to see what happens. Okay, so it set Bob to 0 when it did the maths part, so it says you'll be 10. Okay, so like I've said before, computers are very dumb. Yeah?
Yeah, put in 10 years. 10
Yes,
years.
yes.
So that it didn't do the maths part.
Yeah. Computers are pretty dumb. They'll do exactly what they tell you, you tell them to do, even if you didn't think that's what you said. They are very literal. You okay? Not supposed to inhale it. Okay, so that's reading a number. Okay, now let's do the same thing, but now we're going to look at using strings or characters, and here we're going to use a whole lot of joins. Okay, we do have two variables here called a first initial and a last initial. Can you guys think why we might be using variables in this case?
Sorry, say that again.
We've got two variables, first initial and last initial. Can you think why we might be using variables in this case?
Because you're asking questions before, it could be different.
Okay. The answer variable, the built-in answer variable, only stores the last answer. So if we ask a question, store an answer, ask another question, store the answer again, the second one will overwrite the first one. So we need to have variables to store them. Technically we don't actually need the last initial, but it's just for consistency's sake. You guys got that working? Okay, now when it comes to doing these multiple joins, I suggest you do them piece by piece and then join them all up at the end. So start from the right, do the join last initial and the full stop, then join the full stop plus that block you've just done, then do that join first initial plus the previous block, and so on, because otherwise it can get quite confusing. Okay, work right to left. You're winning there. Should I jump in and do it in real time? Okay, so it's just new. So I'm going to create two variables. First initial, last initial, and then we're going to joins, and I think we needed 4 of them. Okay, and then we needed join last initial plus full stop. So last initial plus full stop, and then we needed full stop plus last initial. Oops. Full stop plus last initial. Then we needed first initial plus that. First initial plus that. And then we needed hello comma. Comma, and put that in like that. You guys managed to do that? Okay, so does it work? Okay, fantastic. Alright, so that was that. This is also available on your flash drive, and I think there's also Ask and Wait 3 if you really want to have a look at it. Okay, this exercise is what we'll start off next week with. It's sort of a new spin on one we've done before, using some of the new stuff that you have covered. Alright. Okay. You are most welcome.